Automatic drip irrigation system. Most people have home gardens and they maintain gardens for various reasons. Some grow for the beauty of it, some as a hobby, and some also as a profitable method. Watering plants takes a lot of time and effort. Sometimes the hose is not long enough, so people have to use a bucket for watering. Most people face these types of troubles in the watering process. Also, unlike the commercial farmers, they cannot fully focus on their home gardens all the time, since they have more important things to do in their life, for example, their profession. This is the main reason behind this project.
We are here to explain 4 of our concepts and their properties a little bit. Concept 1. The first conceptual design portrays a concept of a dripper, where we can actually control the water flow in the delivery tube at the point where the water is dripped. Since the solenoid use only turns one end of the water supply, this concept is needed for this project. Also, this concept portrays about the soil moisture sensor, which is the capacitive soil moisture sensor. Concept 2. In our second conceptual design, we added the rain detection mechanism. The rain sensor works effectively to detect rain by analyzing the water detected by the rain. Main objective of using the mechanism is turn off the system temporarily in heavy rain to save power and water from unnecessary watering. But we needed to find a reliable solution.
Concept 3. In our third conceptual design, we add a fish tank. The tank will supply the water to the plants and the fish will be added to the same tank as the fish excrete waste matter, which is converted to beneficial nutrients that the plants can use. Concept 4. In our fourth conceptual design, we add a remote transmitter for the system to turn on in a remote place, and the overall look of the area was taken from this concept.
If we explain about the process of our system, it is a quite a simple solution. So far there are many options in the market out there as a drip irrigation, but nowhere to be found as automatic drip irrigation except for some students project like ours. So if I directly go into the process of the system. A solenoid valve is an electrically controlled valve. The valve features a solenoid, which is an electric coil with a movable ferromagnetic core in its center. In the rest position, the plunger closes up a small hole. An electrical current through the coil creates a magnetic field. The magnetic field exerts an upward force on the plunger opening the hole, where then the water will be flowing. This is the basic principle that is used to open and close the solenoid valve.
Mentioned here are the main and the battery boxes. We've shown here a system with 2 relays or 2 pathways for the water to travel. Arduino Uno, the heart of the system which controls all the functions. Power supply unit, a 12-volt power supply to convert the AC source to DC and 230 or 110 volts to 12 volts. Relay, this is a dual channel relay mentioned here, which will pass the power to both of the solenoids. Display, where all the data is shown, which includes the system status and the reading from the sensors. A switch, a master switch to turn the system on and off.
Here is the battery box.
Battery pack. This is the battery for the backup system. Single channel relay. This is a relay which has a single pole dual throw which will pass the power from the system or to the system. LED and buzzer. This is warning system to indicate if there are any errors in the system. This works after any errors are detected in the system like irregular readings from the sensor. Battery circuit. 12 volts to 5 volt to charge and 3.7 volt to 12 volt to power the system. LED indicator shows the battery level. Rain sensor is a type of water sensor which is activated by rainfall or water conductivity. It is kept in out and it triggers as soon as it detects any water. The capacitive soil moisture sensor determines the amount of soil moisture by measuring change in capacitance to determine the water content of soil. Water tank. This is the tank where the water is stored, which generates a high and constant pressure for the system to operate.